All right, good morning, everyone. How are we doing? I trust that we are all good. I think I left out a particular question the last time. That was from the question that Emmanuel did. Um, Towards the end of the class, let me solve that question, or maybe I should solve it on paper and send to you. I think that's the best thing to do. I will sketch on paper and then send the answer to you. Meanwhile, well done. You're the only one that did that assignment. Justice left it for me to do for him. But he did very well. So that last one, I'm going to sketch it on paper and send to the group. So this morning we'll be looking at we'll be looking quickly at sets. We'll look at sets and then we'll solve Venn diagram questions because that's the most important or the most expedient um question right there. Yeah, they ask other things actually, but then I think it will find out very fast. All of these ones I think you should have actually read on our own. All those key definitions of sets are things I believe we would have done on our own so that we'll move very fast. So having said that, what is a set, right? Is a word collection of what? Of distinct objects called elements. So all of those things are key things you need to know. So we'll actually make use of a curly bracket to represent your set as you can see on the screen. Yeah, if you can hear me, give me a thumbs up before I continue. If you're here in class, Justice Emmanuel, yeah, please, today's class, I need you to follow through. Stay here on the call. It's not easy doing all of these things. It's for your own good that we're doing this. So now, I say it's a representation of what? Or collection of objects. It's a well-defined collection of distinct objects called elements. I will make use of a curly bracket for it. Now, it can come in two ways. Sometimes they might give you a statement. We'll call it the set builder form. They can give you the set builder form and say this is a set of natural numbers less than 5. Right? It's now up to you to now put up the values. They can have a statement that will be like x, the element x, and that x is a set of what? Real numbers. You can have real numbers, you can have natural numbers, depending on what they want you to do. So it's your own responsibility now to understand these set builders and be able to put up the values. They can tell you that x is an element of set. Okay, x is an element of set A, and x is all real numbers less than 5. Or they can use that minus 5 less than or equal to x, and x is less than or equal to 6. They can give you something like this, inequalities, and using your own hand, you now bring out the values that will be in the set. So what am I trying to say? Not all the sets will come this way. Some of them will come in statement form and use your hand to build them, which means you're going to need the knowledge of key things. You'll be needing the knowledge of what are natural numbers. So that's your assignment. Go and check. We're going to be needing the knowledge of natural numbers, the types of numbers. We'll have integers, we'll have whole numbers, we'll have whole numbers, we'll have real numbers, and sometimes they can say prime numbers. So these are the numbers you should take note of and what they are. Do you understand? So all of those things are key variables you have to take cognizance of: natural numbers, integers, whole number, real numbers. What do they contain? When I say I'm talking about natural number, what are natural numbers? When I'm talking about integers, what are integers? When I'm talking about whole numbers, what are whole numbers? Now, another key thing you should take note of is when it comes to the elements of the set. So example, I have 1, 2, 3, 4. That 1, 2, 3, 4, it simply means that 2, we use the symbol like this, that 2 is an element of set A. If 2 is not an element, example 5 is not an element of set A. You have a slash on it showing that it's not an element of set A. Do you understand? So all of those things are symbols that we need to always remember. So now, and we'll have a list of some of those symbols right here. That basic symbols, you have this, that E belongs to. That means you are a set of that particular element. So this symbol means it doesn't belong, it's not a set. This symbol is for proper set. Then the other symbol is for subsets, empty set, universal set. Complement of a set is A prime, right? If you have that element that has prime on it, it means it's a complement. We'll have union, we'll have intersection, we'll have the cardinality of a set. That's the number of elements in a set. We'll have the power of a set. We're going to solve examples on that so that it makes more sense. Now, having said that, let's look at the different types of set that we have, and then we're going to build on that. So, based on these illustrations, I'm talking about the basic symbols, right? But without you understanding, remember what I said. Take note of these things. What are real numbers? What are integers? What are whole numbers? So these are key things I want you to actually go and check out for, so you know what the values represent and what the numbers are actually talking about. So now let's look at the different types of sets. My goal today is to solve Venn diagram question, because all of these ones are GST questions that we're expected to read up on our own. So an empty set, it has no set within it. So if you have something like this, and we use this symbol to illustrate that it's an empty set, right? Or you can use something like this, an empty set. It has no set within it. Is that okay? Now, we'll have your universal set, U, which is total set you are discussing about. That's universal set. I'm in the jam center. So what's happening in the jam center? You are registering today? Emmanuel? Emmanuel, you're in a jam center. Are you there to register? I'm off to register jam in case I didn't pay maximum attention. Okay. Justice, are you registering for jam as well?
No.
All right. So both of us are in this class. So pay attention. So we have the types of sets, as you can see. I've spoken about empty sets. We'll have your universal sets. Then we'll have complement of a set. For example, let's say we have a universal set U, and let's say that that set comprises of 1, 2, 3, 4, and 5. Now, and I'm looking for, and let's say I have another set A, and set A is equal to 1, 2, 3. Then complement of the set A prime is simply asking me what are those elements in U that are not in A. Do you understand? That's the complement. So, and those elements in U that I cannot see in A is what? 4 and 5. So that's the what? The complement of what? Of a set. They represent the complement of a set. Does that make sense? So we've looked at what an empty set is. An empty set has no elements inside of it. We looked at universal set. That's the total set you are talking about. What we are discussing about. Everything, just like the name implies, universal set. So the next one is what? Is the complement of a set. Set that is in A, which is not in universal set. And A is a subset. Do you understand? A is, if you check, all the elements of A are in U. So we can say that A is a subset of what? Of U. Does that make sense? So that symbol for subset, look at the symbol for subset here. You can see that symbol at the center, right? That's the symbol that we use for the what? The subset of A. That A is a subset of what? Of B. Does it make sense? Which means that A, all the elements of A are in B. So for this our example now, I can say that A is a subset of U, which means that all the elements of A are in what? Are in U. So that is what? Subset. So subset simply implies that every element in a particular one is in the other one. So for example, now, if I want to illustrate my subset, what I can say about subset, let's say I have A, let's say that A is equal to this 1 and 2. And let's say that B, are you there? That B is 1, 2, 3, 4. So I can say that A is a subset of what? B, because A is coming from B, and all the elements that is in A is actually what? Inside of what? B. Now we have what we call a finite set. A finite set has a limited set, like it doesn't continue. So you can have something like 1, 2, 3, 4, 5. It doesn't continue. So a set that will know where the elements stop. We have an infinite set, that one continues. Does it make sense? Now we have a disjoint set. So what are disjoint sets? Example now. Let me erase some of these things now. Let's talk about disjoint sets. So what do we mean by two sets are disjoint, right? So what we mean is that when you have an element, say we have A, and I have 1, 2, 3, and then I have B, and let's say that B is 4, 5, 6. So they don't have anything in common. Do you understand now? So two sets with nothing in what? With no elements in common. They don't have anything in common. That's why if you look at this, you have A intercept B is equal to 0, meaning that they don't have anything in common. right? So if you check, what do they have in common? They have nothing in common. So that means A intercept B is an empty set. They don't have anything in common. So a disjoint set has nothing in common. Do you understand? Infinite set, the elements are endless. Finite set has limited element. Subset means that all the elements of A are in B. So these are key things that we need to know. Are you listening now? Justice, are you still with me? All right, beautiful. So the next thing I want to speak about, which is not here, is your cardinality, right? Cardinality means the number of elements in a set, right? So that's a particular key thing that we need to talk about. So let me just include that very slide right here so that it will make sense. Sorry, this is too big. So let's talk about cardinality of sets. Cardinality will just tell us the number of sets that a particular number of elements will have in a set. So cardinality. So the cardinality means you are just counting the number of elements in the set. So for example, let's say that if A is equal to, let's have this element, let's have 2, 4, 6, and 8. Hmm? Then what it means is that the cardinality, which we write this way, we write it as n open bracket A is equal to 4, which means there are 4 elements in that very word set. So cardinality has to do with what? The number of elements in a set. Now, and there are key formulas you need to know, right? So cardinality formulas you need to know, just take note of them should in case they ask. So cardinality formulas, which has to do with the number of elements in a set that we need to know, is that when you have number one, the number of elements in A union B. Do you know what is A union B? Hmm? I think I'm going to talk about A union B. Like, I didn't talk about the operations in a set. Okay, before I talk about this cardinality, let's look at the operations of a set before I talk about that. I think that will make more sense. Instead of skipping to this, let's look at operations in a set. All right, so I've talked about the different types of sets. Um, let's look at the operations or the basic things we can have in a set. So now, operations on a set, we have the union, we have intersection, we have difference, and we have complement. So union now is that elements in A or B or both of them, you are bringing them together. Are we on the same page? If we're together, can you give me a thumbs up? Good. So that's for the operations of a set. So we've looked at the types of sets: universal sets, complement sets, subsets, disjoint sets. The next thing we are going to talk about is the union of a set. So let's have that the value of A, let's say that A is 1, 2, and 3. And let's say that B is 4, 5, and 6. So when I say A union B, simply means I'm bringing everything together. So it's going to be 1, 2, 3, 4, 5, and 6. We're bringing them together. That is union. Now, if I want to talk about intersection, A intercept B is what they have in common. Okay. Now, let's assume that we have 4 here. Let's assume we have 4 right here. So what they have in common is going to be what? 4. That's the intercept. What we have in common is simply what? The intercept, right? Now, the next thing is the difference of a set, right? A minus B simply means elements in A, but not in B, like you can see here. So when you are subtracting, you are looking for those elements that are in A, that are not what? In B. But remember that A minus B is not equal to B minus A. They are two different things, right? So A minus B is elements in A but not in B. B minus A is what? Elements in B but not in A. So they are two different things. Now I've also explained complement of a set already. That operation that has to do with the complement of a set. I've explained what the complement of the set is all about. So sometimes you can have those little questions asking you about the union of the sets, asking you about the complement of the sets, the intersection of the sets, and the difference between two sets. So that said, let me now proceed over to the cardinality of our set. Do you understand the operations of the set now? And when you are giving questions, I sure do hope that you'll be able to tackle them. Is that also? Good. So take note of that. And that will help us when it comes to, what do you call it? It will help us when we come to, we also have equal sets. Two sets are equal if they have exactly the same elements. I just remember now, have equal sets. So when we talk about equal sets, so here now, we'll have equal sets. So they have same elements. All together, if they contain the same elements. Good. So equal sets, they will have the same elements. Right? I think then equivalent sets, they will have what we call equivalent sets. They're equivalent if they have the same number of elements, right? Equivalent sets, same number of elements. They have same number of elements. So these are key things I forgot. So I think I've given you the key variables that we need. So let's now go straight to the cardinality I was talking about, which has to do with the number of words of sets. So now, if you have the cardinality formulas, is that the number of sets in A union B. Are we there now? I've talked about intersection, I've talked about difference, I've talked about complements. The cardinality has to do with the number of elements in a particular stuff, right? I've spoken about that. So now the next thing is about the cardinality of a set. Now for your cardinality, you have NAUB. What does it imply? How many what's the number of elements that we have in that kind of set where you are having the union of a set? Now that formula is a formula I want you to always remember at every point in time, and the formula goes like this. It simply means that this is equal to, you're going to take cognizance of the number of elements in A plus the number of elements in B, are we together now? Then minus the number of elements in A intercept B. So let me write properly. A intercept B. That is when you have A union B. Then for three sets, this is for what? For NB. This is for two sets. Now let's assume that we have three sets. Let's say we have the number of sets in A union B union C. What will it give us? We'll go one after the other. We're going to have NA. Idea. We're going to have NA. Then thank you. NA. Then I'm going to split each and every one of them just that way. So I'm going to have NA plus NB. And what you can do for me, start looking for questions, right? So that I can just solve a little questions and then we'll move over to Venn diagram, right? So that will make the entire work easier for us. Then that of associative properties, I think I'm going to leave that one for you, basically. Yes, I should leave it for you. So you can actually have something to do, and then we'll save our time for other stuffs. All right.
Would
All
it
right.
also
So
have,
I didn't hear you.
I wanted to know if it also have minus A
Yeah,
union
it
B.
has. Yes. So it's going to have intercept B, right, minus this A intercept C. Are you there? Then that one happens to be the longest, minus NB intercept C, right, plus N is going to have A intercept. Sorry, I'm not writing properly again. It's going to have then everything together plus NA intercept B intercept C. That is for three sets. So what happened there is that you take each and every one of them and then you end with their intercepts. Is that okay? So for the three sets, this is for three sets. Why this one is for two sets? That's for the cardinality. Remember, cardinality has to do with just what? the number of sets, the number of elements in a particular set. That's what your cardinality is all about, right? Now, sometimes they can ask you about the power of a set. The power of a set is simply trying to tell you the number of subsets that you can actually get from a particular set, right? So let's talk about power of a set. I can remember questions usually come from that side. So we can have power of a set, right? Or power set, actually. Let's call it power set. So the power set will give you what? The numbers of what? Set of all possible, right, subsets of all possible subsets of what? Of a given set. Good. So now let's say we have if you have there's a formula we normally use, right? Let's say that we have a set that A is equal to, let's say, 1, 2, 3, 4, 5, 6. Now the power set, which means the number of subsets I can get from it, the power set, which is PA, will now be equal to what? 2 raised power n, where n is the number of elements in that set. Are we together? N is the number of elements in that set. So good. Where n is the number of elements in the set. Right? So that means that for this one, we'll have how many elements? 1, 2, 6 elements. So we'll have that here, n is equal to 6. So the power set will now be equal to 2 raised power 6. So power set, 2 raised power 6 is what? I know 2 raised power 4 is 16. 16 times 2 is 32. 32 times 2 should give us 64. So 64. Is that also? Good. 64. So that means that the number of subsets that can come from that very set, number of subsets will be equal to 64. We can have 64 number of subsets coming out from that very set. So that's how we get the number of what? Of subsets, right? So number of subsets, power set is also the same thing as number of subsets. So we call it PA. So power set is number of what? Of the what? Of the subset. So once you have that, you can easily what? Navigate to get the power of the set. Now, sometimes, right? They can give you questions can come like this. You can have tricky questions like this. Example, you can have that the number of subsets of sets A is, they can say, let's say is 16, right? Find the number of sets. Sorry, find the number of elements. Find the number of elements in the set. Find the number of elements in the set. So what that implies is that they've given you what your power set is. Remember that power set is equal to what? 2 raised power n. So the number of subset already is 16 is equal to 2 to the power of n. You are looking for n, is that also? Now, according to your indices, right? 2 raised power 16 is something as 2 raised power 5, which is equal to 2 raised power n. So I'm applying indices here, right? So that means that 2 here will cancel 2, and you're going to have that the number of elements n is equal to 5. So number of elements in that set, the number of elements will now be equal to what? 5 elements. So sometimes they will give you the power set or the number of subsets and then ask you to find the number of elements that will have inside of them. So you've looked at the types of sets, I've looked at the operations in a set, then I've looked at the cardinality of a set. All of these things are key things that can be what? Can be asked. Complement of a set, difference between two sets. And I told you that it is very key to always remember that A minus B and B minus A. that they are not the words, they are not the same words, they are not the same thing. Sometimes questions can come from there, and it can be funny sometimes, right? And it's very key. So power sets, I've given you the cardinality, I've talked about the difference, I've talked about intersection, I've talked about union, infinity sets, equivalent sets, equal sets, subsets, universal sets, and the representations of what? Of your set. Now let me talk about important set rules, right? There are some set rules we need to know, right? So set rules. Let's look at set rules. Now, the first one, you've heard about your commutative. Something is commutative, like 5 times 6 is the same thing as 6 times. Sorry, 5 times is something as 6 times 5. They are commutative, right? 5 times 6 and 6 times 5. Are you there now? 5 plus 6 and 5 plus 6 and 6 plus 5. So they are commutative. Are you seeing it now? So let's look at what the commutative laws. Do you understand what I mean by commutative? Remember that subtraction is not commutative. 6 minus 5 and 5 minus 6 is not the same thing. But 6 plus 5 and 5 plus 6 will give you the same answer. So now, for commutative laws, good. We have that A union B is equal to B union A, right? And A intercept B is equal to B intercept A. Let's show an example. Let's say that A is equal to, let's have 1, 2, and 3. And let's have that B is equal to, let's have 3, 4, 5, and 6. Now, when we do A union B will now be bringing them together. So 1, 2, 3, 4, 5, and 6. Is that not so? Now, let's check again. B union A will still be the same thing because we're bringing elements that they have, all the elements in them, we're bringing them together. So it's the same thing as what? 1, 2, 3, 4, 5, and 6. Are you there now? Now, let's look at A intercept B. Good. So now, let's look at A intercept B. You could see that I will have, what they have in common is what? Is 3. Then B intercept A will still give you the what? The same 3. So they are what? They are commutative. Union and intercept are what? Commutative. So what are we trying to draw out from here is that union and your intersection are commutative. So these are key points you need to always remember at every point in time. So the next one is the associative law. Remember the associative law back then, when you are trying to multiply. I'll give you an example so you understand what I mean by associative. The associative law. So for your associative law, remember in mathematics that how do we normally do it? 3 times 2 plus 5 should be same thing as 3 times 2 plus 5. Let's check. 3 times 2. 2 plus 5 is 7. 3 times am I correct? 7. 3 times 7 is 21. I'm wrong, right? I think that's not how to do it. That's not how to do. That's not how to do associative. That's not how to do associative. I'm just trying to bring back our associative law. A plus B plus C. Okay, yeah. Let me use this way. A plus B plus C and A plus B plus C. So let's check. So let's say I have, let's use numbers. So let's say I have 5 plus 3 plus 4. This will give us what? 7 plus 5. That will give us what? 7 plus 5, 8, 9, 10, 11, 12 should give us 12. Right? So now let's change it now. Let's now bring a bracket. B is 3. Okay, I have that A equal 5, B equal 3, and C is equal 4. So now I'm bringing them inside bracket. I have 5 plus 3, and then C is 4. So I have that 8 plus 4 is equal to 12. So that's the right thing to do. Sorry about that error. So this is associative law. And that associative law still holds for what do you call it? Still holds for sets. So now when you have A union B union C, are you there? It is equal to A union B. Good. A union, you can open up the bracket. You can have A open bracket B union C. They will give you the same thing. And that A intercept B intercept C will give you the same thing as when you do A open bracket, yeah, intercept B intercept C, like this. So when you check this, they're going to give you the same value, just like what I did in multiplication now. So A union B, A can still come outside, right? So that you have B and C. So these are the what? Associative what? Property. Now the next one is your distributive property. And we're going to see how it relates. You can verify this. You can verify this stuff here to see whether you're going to have the same value. So you can actually diverse your own sets, diverse a set A, diverse set B, diverse set C. Okay, let's try it out. All right, so that we don't assume anything. So let's say that A is equal to, let's have 1, 2, and 3. Let's have that B is equal to 3, 4, 5. And let's have that C is equal to 5, 6, and 7. Now let's look at A union B. A union B will be equal to what? 1, 2, 3, 4, and 5. Then A union B union C will be equal to, I'm now bringing C there now. I'll have 1, 2, 3, 4, 5, 6, 7. Now let's check the other way around. Let's check B union C. So B union C. Let's check B union C. B union C. B union C. Are you still with me? B union C will be what? 3, 4, yeah, 5, 6, and 7. So that A union B union C will now be equal to what? You will see I'm going to have 1, 2, 3, 4, 5, 6, and 7. So you can see that that very rule of A union B union C being the same thing as what? A union B union C. Are you seeing it now? So if you try that of intercepts, you should as well get the same value. So that's the very associative law of for your sets. Then the third one we should look at is your distributive law. So for your distributive law, if I have A intercept B intercept C is the same thing, sorry, not intercept, we'll have union. More like you have A plus 3 times 5, you can distribute, or 3 times A plus B, so you multiply through. So now this will give us A union B, idea. Then not A union B, that should be A intercept B, please. Because I'm opening up the bracket. A intercept B. Yeah, this will be correct. Then I have my union. Then I have my A intercept C. Are we together? More like I'm opening up the bracket. Distributive law. Good. More like A intercept B. A, Then you have your union in between. Then A intercept C, more like opening up the bracket. Then the next one, that's what your distributive law is all about. I have A intercept B intercept C. Will simply be the same thing. A intercept open bracket this time around. B intercept C. When you verify this, you are going to get the same thing. Now, the last one, which is identity law, which most Christians will come from identity law sometimes. So we'll have the identity law, right? That has to do with multiplication. If you take the union of a set, A union of an empty set, it will give you A, right? If you do A intercept of a universal set, it should give you A. All right, so that said, all of these things are the key equations that we need to take note of. Any question on that? Good. There's another law. Let's take this law. Let's take the Morgan's law. The Morgan's law. This one has to do with your complement. So the Morgan's law, when I have A union B complement, that means when you compile the values of your A and your B, and then you take the complement, right? So bring in A, bring in union B, then the complement. What is in A union B that is not in the universal set is this, that this is also equal to complement of A intercept complement of B. This Morgan's law is very, very important. Also, that A intercept B is equal to A prime union B prime. That's the complement. Even if you forget any other thing, you see this De Morgan's law, it should be handy. It's one that we mustn't forget, and it's one that we mustn't play around with. So these are the basic laws, and I think that it can be our working document. Is that okay? Any questions so far? So these are the key laws, and these are the key things we need to know about our set. So if you have any past questions with you, right, we can get our hands dirty with that. But in the absence of that, I think you can go ahead and apply everything we've done in all of these things. So I've looked at the important law is even here, commutative, distributive. I have even complement is here. Then I have the Morgan's law. Let me bring it up a bit. I have the Morgan's law as well. The Morgan's law is here. So all of those laws are key things that we need to know right there. So commutative, the Morgan's law is down. Before I now spoke about your canality of a set, which is the number of sets you have, the formulas and everything that we need to know in your set. All right. So that said, let's look at your Venn diagram and let's look at questions regarding the Venn diagram. So let's look at your Venn diagram. So for the Venn diagram, I want to solve questions that involves three diagrams. Now, if you understand where you have three sets, like three sets, 1, 2, 3, because the maximum they will ask you is three sets. So I want to solve a question that involves three sets. And with that, there's no question on Venn diagram that you'll not be able to handle. So let's just look at it together. If you have questions, you ask me. It's going to be a long one, a very long question. But after that, there's no Venn diagram question that you will struggle with. There's no Venn diagram question you will struggle with. So let's take that the question now. That in a class, are we together? If you are still with me, give me a thumbs up. Good. So in a class, of 50 students, 24 like football, 21 like basketball, and 18 like cricket. Full stop. 6 like football, and basketball only. 3 like basketball only. Hmm? 3 like basketball only. Full stop or comma instead. 5 like all 3 games. Hmm? And 14 did not like any of the 3 games. All right, so now in this Venn diagram, I want you to pay attention to key things. When they say only, pay attention to this keyword only. Pay attention to 3 like football, only 5 like all 3 games. Pay attention to the word and. So now, but the keyword I want you to pay attention to when they say only. So now we're going to document all of these things and then we'll solve accordingly. Now, solution. We're going to write down the key variables they gave us. They said that there are in a class of 50 students. That means that the universal set is 50. So universal, which we use U, so universal in brackets U is equal to what? 50 students. Now they went ahead to say that 24 like football. So football equal what? 20 what? We have 24 persons or 24 people rather that like football. Then the next one is 21 like basketball. So we have basketball, 21 likes basketball. Now, 18 like cricket. So we'll have 3 games right there. So the next one we'll have here is your cricket. And we'll have 18 of them that likes cricket. Now, it didn't end here. They went ahead to say that 6 like football and basketball. Now, football and basketball. So remember that and simply means when you have um a intercept. Is that also? Football and basketball talks about your is it intercept or union? Which one? It talks about your intercept, right? Intersection between them. Good. So football, let's use F, and basketball, football and basketball. This is like football and basketball only, right? So football and basketball only. They have how many of them do you have there? 6 of them. Now the next information I have is that 3 like basketball only. That word only is very important. So basketball, sorry, yeah, basketball in brackets only is how many students? Basketball only will have 3. Now the next information we'll have is that 5 like all the 3 games. We have 5 persons that like both basketball, football, and cricket. So we have football and basketball and cricket. And based on our set notation, this means F intersect basketball intersect cricket is equal to 5 of them. All right. And 14 did not like any of them, right? 14 did not like what? Any of them. So that means that For that 14, it means the number that likes what you don't have for union B, union C is equal to 14 that doesn't like what any of them, but that should be the complement, right? When you bring in F, bring in U, bring in C, what is in F, in B, in C that is not in the universal complement is 14 of them. In the universal set, I mean to say, is 14 of them. So with this information now, we can draw our Venn diagram. So now let's draw this Venn diagram outside. Remember that we have key variables where there's an intersection. Football and basket, there's an intersection. Football, basketball, and cricket, there's an intersection. So let's go ahead and draw our stuff. So let's have the box first of all. Or let me draw the circle, then I'll get the box. So let's have the first circle. Let's have the second circle. There will be an intersection between them. Let's have the third circle. There will also be an intersection between them. Now, let's put our box outside here. All right. So now, remember, we can name this. So for basketball, we have, okay, universal set will have 20. So outside our stuff, are we together now? We'll have that U, we'll have U is equal to 50. The universal set U is equal to 50 students. Now, the next information we'll have right here is that football is 24, right? So let's place it outside here. For football, the number here is 24. Now, the next that we have is basketball is 21 and cricket is 18. Let's have basketball 21, and let's have cricket to be 18. So these are the informations we have. But it didn't end there. There are other small details we are going to take note of, right? So we said that football and basketball will have 16 persons. So for football, for 6 persons rather. So football, basketball will have 6 right here. Are you there now? Now, the next thing I have is that basketball only, that word only. So those that do only basketball will have how many of them? 3 like basketball only. So that means inside here, I'm going to have 3 for my basketball. So 3 persons basketball only. Now, the next key point we have here is that 5 of them like all 3 of them. So at the center for football, basketball, and cricket, the number of them that like the 3 of them is going to be what? Is going to be what? 5 of them. Now, but if you observe, you can now see that we don't have any number here we don't have football only, right? We don't have cricket only. We don't have football and cricket. Let's call it what? WXY. Let's call here Z. Are you seeing it now? That's football and cricket only. Now let's call here P as well. That is what? Basketball and cricket. So what are those variables we are trying to string together now? So now let's football only, let it be what? Be X. That's the number of person that has football only. Now let's cricket only. Cricket only is going to be Y. Justice, are you following? Emmanuel, are you following? So cricket only, good. Let it be what? Let it be Y. Now the next one I have only here, I've accommodated for football only. I've given for cricket. Then the next one is what? Football and cricket be Z. So number of football and cricket be equal to what? What alphabet did I give there? I gave it Z. Now the next intercept we have is what? Cricket and basketball and cricket only. So basketball and cricket. Sorry. Yeah, am I correct? Yeah, cricket. Basketball and cricket. We said let it be equal to what? P. So these are the key variables that we have. And with these key variables, we can proceed with solving our questions. So now, one key thing I want you to know is that all of these variables, football will have its own equation, basketball will have its own equation, cricket will have its own equation. So all three of them will have their equation. Universal set as well will have its own what equation, and that equation will be stemming from what the data or the information that we have right here on the screen. So based on this circle, based on this, we're going to take the details of the universal set and everything that has to do with that. So that said, let's proceed. So first of all, let's look at the football equation for football. So let's consider football. So I'm going to take everything that is within the circle for football. Now check the number so we can keep track of it. So for football, we have x plus 6 plus 5 plus z is equal to 24. So these are the variables we have inside football: x, 6, 5, and z. So we have x, 6, 5, and z. So x, 6, 5, and z is equal 24. Do you understand what I did right there? So I'm bringing everything that has to do with the circle. So each circle will form an equation. Makes sense? So all circle will form an equation, right? If you have two circles, that means two equations with universal sets making it 3. If you have 3 sets question, the most is 3, and that's why I started with 3. You're going to have 3 equations with universal set equation making it 4. That way, there's no question you cannot solve as long as set is involved. So after this, you can go and check out past questions, and you'll be glad you did. So now let's continue. This will give me x plus z plus 11 is equal 24. So that x plus z is equal 24 minus 11. X plus z, so give us 13, right? Is equal 13. Now, this will be my equation number 1. And we're going to make reference to this equation later on. So this is our equation number 1. This is our equation 1. All right. So the next one I'm going to look at, we looked at football. Let's look at basketball. And for basketball, the same process. We take everything inside our basketball. So for basketball, remember if I'm in the exam hall, by now I'll be done with all of these things. So the faster the more you solve, the easier it becomes. So what do we have inside the circle of basketball? We'll have 6, 5, 3, and P. So 6, 5, 3, and P. So we'll have 6, 5, 3, and P is equal to how many persons like football, basketball rather? There are 21 of them. So this is equal to what? This is equal 21. Now, but we can simplify this thing further. When we simplify further, we should have that 6 plus 5 is 11. 11 plus 3 should give us 14. So I have 14 plus P equal 21. So therefore, I can get the value of P, and the value of P is equal to 21 minus 14. So that P is equal to, this will give me 7, 6 plus 20. Yeah, so this will give me 7. P is equal to 7. So this is my what? Equation number 2. And that is the equation coming from my what? My basketball. Great. Now the next one, after the basketball, we're going to be looking at what? Our cricket, right? So how many persons like cricket are going to form the equation around the cricket? So for cricket, we observe that of cricket. And for cricket, how many do we have here? We have 5, Z, P, and Y. I think that place has the highest unknown. 5, P, Z, and Y. So we have 5, P, Z, and Y is equal to how many persons like cricket? So total number of persons that like cricket is equal to 18. Is that not so? But from equation 2, we have that P is equal to 7. So we're going to plug in the value of P right there. So we have that 5 plus 7 plus Z plus Y is equal to what? 18. 5 plus 7 is what? Justice.
Twelve.
To show you're following me.
12.
12,
12.
right? 12. Is that what you said?
Yes.
Good, 12. So that will give us 12 plus Z plus Y is equal to 18. So that means that Z plus Y is equal to 18 minus 12. Now, that means that Z plus Y is equal to 6. And that will give birth to our what? Equation number 3. Is that also? This will give birth to our what? Equation number 3. We'll have a particular value right here. Then finally is the universal equation. Now, the universal set, which has to do with every other thing inside of here, excluding these guys. You're not going to bring these ones. So these ones and these are our universal set equal to 50. So for the universal, we're bringing in everything together, right? So for universal, check everything you have for the universal, right? And remember, for that very question, I didn't even complete the question. So for this question, we want to get, we want to draw the Venn diagram and want to get the number of students that like football only. Sorry, the number of students that like this unknowns we're looking for. Number of students that like football only. Number of students that like cricket only. Number of students that like basketball and cricket. And number of students that like football and cricket. That's what we want to find for that very question, right? Right there. Do you understand? That very question I'm solving now. I'm just trying to solve everything. So these are the kind of questions you'll be seeing. The one that like cricket and this, cricket and this. So for the universal set, I have 6. I have x plus 6 plus 5 plus z, right? X plus 6 plus 5 plus z. So we'll have x plus 6 plus 5 plus p plus, yeah, so x plus 6 plus 5 plus p plus 3 plus z plus y. So plus 3 plus z plus y, all of them is equal 50. Now let's bring it up together now. Let's bring those alphabets, x plus z plus y, right? Plus p, right? So plus 6 plus 5 plus 3 equal 50. So I have x plus z plus y plus p. 6 plus 5 is 11. 11 plus 3 is 14. So 14 is equal 50. X plus z plus y plus p is equal to 50 minus 14. X plus z plus y plus p is equal to 50 minus 10 is 40. 40 minus 4. I'm correct, right? 40 minus 4 to give us 36. So I have 36.
Sir,
I didn't hear you.
I
I
thought you
didn't hear you.
have P already. I thought you have P already.
Hey, yeah, thank you. So now let's go in and plug some things. We have the value of p. P is equal to 7. And you even have x plus z, right? Z plus y. So we have p already. We have this p. We have z plus y. So from equation 2 and 3, right? So from equation 2 and 3, from equation 2 and 3, we have that z plus y is 6. And we also have that p is equal to 7. So we have that. That means our question is solved. So this is x plus 6 plus 7 equal 36. So x is equal to 6 plus 7 to give us 13 equal 36. X equal 36 minus 13, right? So what's the value of x? 30 minus 10 is 20. Is that not so? 36 minus 3 will give us 33. 33 minus 10. So x is 23. Is that also? Justice, are you still here? Yeah, 23. So x is equal to what? 23. Now, that's with this, we can now, this is our equation number 4. We can now get something. Is that also? We can get our z. Is that also? Z plus y is equal to, are we omitting anything? Good. So let's go to equation 1. So from equation 1, I have x plus z is 13, right? So from equation 1, we'll have that x plus z is equal to 13. So this is 23 plus z is equal to 13. Check well. It will give us a negative sign. This is 50. 6 plus 5. Z plus this. That's x plus y is 6. P equals 7. All right. Check. Am I making any mistake right here? Let's check.
Sir,
So
I
50
thought
minus.
we have x
I didn't
plus
hear
z
you.
13. We have x plus z 13, x plus z 13, and z plus y 6. So I don't understand.
X plus z is 13, right?
And z plus y 6. We use both of them
And
in
z.
the
No, we
z
cannot
plus
use.
y.
We don't know the. We don't know the value of y, so we cannot use z plus y.
Okay.
We have to get the value of z before we can now find the value of y. Do you understand?
Yes.
So yeah, we cannot do that. So we have to get the value of. So what I'm checking now is 50 minus 10 is 40. I'm checking my subtractions to be sure that there's no error here. There's no error, right?
Yes.
So let's just check those subtractions. If there's no error, then we are good to go. Any other thing omitted there? So I plugged in z plus y. I had that p is equal to 7 from our calculations. So if all of those things are okay, then I can continue. All right, so that's subtracted 36. Then you said that x is equal to 23. That our x is too big. Oh. The value of x looks a little bit big. The value of x looks a little bit big, and there might be an error right here. Okay, let me quickly trace my steps, okay? So I have x plus 6 plus 5 equal 24. S plus z is equal to 13. Makes sense. Then basketball, 6 plus 5 plus p plus 3. 6 plus 5 plus 3 plus p. 6 plus 5 should give us what? Number of basketball. Hope I didn't pick any wrong value here. Number of basketball is 21. Yes, this one I've been scrolling up and down. It's very high tendencies. So 6 plus 5 is 11. 11 plus 3 is 14. 21 minus 14 should give us p equals 7. Yes. So cricket is 5 plus p plus z plus y. So cricket 5 plus b plus z plus y is equal to 18. Yeah, we'll plug the value of p. So 5 plus 7, 9, 10, 11, 12. Yes, 18 minus 12 is equal to 6. Makes sense. Universal sets, I have x plus 6 plus 5 plus z plus y plus p plus 3. Plus y plus p plus 6 plus 5 plus 3. Beautiful. 6 plus 5 is 11. This is 14. 50 minus 14, that is 36. So from equation 2 and 3, we'll plug in our values. We'll have that p is 7. Good. So I have 36 minus 13, which will give us 36. So x 23 plus z equal to 13. That will give us a negative sign. That will actually give us a negative sign, and it's not possible. There is something I must have done wrongly somewhere, and I'm trying to trace it. Are you still with me, Justice? there must be something we must have done wrongly. Yes, there is something we must have done wrongly that we'll quickly need to trace back and know where that error is coming from. There's something we must have done wrongly. Yeah, there must be. 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 There must has been an error somewhere. There must have been an error somewhere. There must have been. So I have this place is 7. Right. Mm-hmm. 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 There must have been. There must have been. There must have been. Oh yeah. We forgot about this number here. Sorry, I didn't even indicate it. Nigga, good. So don't make that. Look at it here. 14 did not like any of the games. Can you see that? 14 did not like any of the games. So that 14 that didn't like any, even I didn't even indicate in the diagram. So that 14 that didn't like any of the games, and that was what made our answer off. Yeah, so there should be a 14. You cannot have negative sign there. There should be a 14 right there. So now, which implies that right here, our universal is not yet complete. We should add our 14 right here. Does it make sense now? Yeah, so I should have plus 14 is equal to 50. Makes sense. So that thing was not really complete, right? We didn't include neither. It should be part of the universal set. Plus 14 is equal to 50. So I have 14 plus 14. Everything here should give us 28 right here. Then 50 minus 28 will give us what?
22.
20 what?
2.
22, right? Good. So now we can now plug in those values that we saw, right? That was a very costly mistake. So now 22 right here. So equation 2 and 3 will have 6 plus y is equal to what I have here is 22. Is that not so? So now I have 13, I have 22. So 22 minus 13 will give us what? 22 minus 13, justice. So we can go over and finish up, please.
9.
Are you still in class? 9.
9.
So okay, so x equal 9. All right, so you can trace back our steps now. Check whether is there any error anywhere at this point. I don't think there is. Now, so we can now put our answer x equal to this. Good, and then this will now make sense that x plus z is equal to 13. Then x is 9, right? So that z will now be equal to what? 13 minus 9, and z is equal to what? This should give us 4. Is that not so? Hmm? Then remember that there's something else we left out, right? We left out y z plus y, which is equation 3. So from equation 3, from equation 3, we have that z plus y equals 6. So 4 plus y equals 6. So that y is equal to 6 minus 4. Y is equal to. Now, we can now report our answer. Remember, we said that x is football only. So, and that x is equal to 9. So, we'll have football only is equal to 9. Then the next one, we'll have football only equal 9. Cricket only, which is our y is equal to 6, 2. So, number of persons that like cricket only is equal to 2. Then the number of those that like, which other one? Cricket only. Football and cricket is z. And football and cricket will get it to be 4. So football and cricket, that is F intercept C, is equal to 4. That's football and cricket. Then the next one, are you there? Football and cricket. Then basketball and cricket, we'll call it P. P is 7. So basketball and cricket is 7. So basketball and cricket, that is B intercept C, is equal 7. So now we can now put up our diagram and complete our diagram, right? So that everything, the missing values, will now be included right there. Oh, sorry, I can't copy. Yeah, because of the document. All right, so that's what we have there. So you include the values. So remember that the question we're asked to find, we're trying to find what? Number of students that did. Let me move this solution a bit so we can have space to write. I can't even move it because of the documents. So, but you understand, we're looking for those that did basketball only, football only, and the rest of them. So that's exactly what we calculated. You can check for your past questions. Let's see other questions. If you have other Venn diagram questions, bring it on so we can solve them. I'll leave it to you. Do you have any other one? We should be able to solve plenty of them. We should be able to solve plenty of them. Venn diagram questions, you bring it on so we can handle them. Are you bringing question or should I get mine?
I get yours.
I didn't hear you.
Yours. This is yours.
Okay, I should get mine. Okay.
Uh,
Okay. Okay, so look at JAM 1999. Are you there? So JAM 1999 says that a group of women sell at least, I wish I can just get a screenshot of it and just paste it. Yeah, let me do that. It will save us time. Now I told you guys to get your own questions. So I was thinking that people will come with questions. All right, so let me send JAM. This is JAM 1999. All right, so I've sent it. Let me get it from here. All right. All right. So look at the question here. Can you see it now? A group of market women sell at least, we have yam, plantain, and maize. 12 of them sell maize. 10 sell yam. 14 sell plantain. So now I want to make use of a small these small sides so that we can see what we are doing. Let's just make use of, let's reduce it a bit. But I hope you can still see the question even as I'm reducing it. Right. So let's write down the details. So we have plantain, maize, and yam. So let's have plantain. I'll write it this way: n maize is equal to 21. Sorry, what am I saying? Is equal to 12. Then we'll have the next one there, which is n yam, which is y. The number of persons selling yam is 10. Number of persons selling plantain is equal to 14. 5 sell plantain and maize, right? So number selling plantain and maize is equal to 5. Number selling yam and plantain, selling yam and maize is equal to 4. Number selling yam and plantain is equal to 2. Okay, only Y3 sell all the 3 items. Are you there now? Did you what happened there? They said that what? How many? Good. Makes sense. So number of maize is 12. Number of yam, 10. Number of plantain, 14. Number of plantain and maize, 5. Number of yam and maize, 4. Number of yam and plantain, 2. That's exactly what we have. Now, it didn't just end there. They said that all the 3 of them, which means yam, let's start with maize, which means maize, yam, plantain is equal to what? 3 of them. Now, what we're going to do, we need to draw our circle, right? So let me reduce the bit so I can be seeing it while drawing the circle. So for our circle, we have 3 of them. This is the first. And they're asking us about how many women are in the group. So universal set is purely unknown. Now we have the second one and we have the third one. Because of space, I will not draw the box. So now we have n here, n maize equal 12. N yam is equal 10. N plantain, are you there? M plantain equal 14. Thank you. Now, 12 of them, so good. So now, people that sell maize and plantain will have 5 of them. People that sell yam and plantain and maize, I've done that. Plantain, maize. I think I'm making mistake here. Yeah. Plantain and maize, so M and P. Yes, there are 5 of them, which is here. Then yam and M, Y and M, will have 4 of them. The next one is Y and P, we'll have 2 of them. And then 3 of them are doing everything. Are you seeing it now? Does it make sense? So they've both given us this value, this value, this value here. And they're asking us now, how many women are there in the group? Now, remember that these very equations that you need, right? The variables you need to get here numbers that has maize only, people that have yam only, people that have plantain only. Sorry, this is bad. Y, and let's here be Z. If you understand what I'm saying. Because of what? To get the universal set. Remember, for the universal set, for the universal, what I need to get the universal, which is what they are asking me, is that I need people that will do maize only, plus people that do yam only, plus people that do plantain only, plus all the variables I have, 5, plus 4, plus 3, plus 2, right? Will give me equal to what? U, which is the group of women. So this is what? Group, right? Of what? Of W, of women. Now, but it's not complete. Therefore, I need to find my X, I need to find my Y, and I need to find my Z. Now, doing that, I have that for maize, I have X. Observe that box for maize. You have X, 4, 3, and 5. So I have X plus 4 plus 3 plus 5 is equal to, how many of them are working with maize? 12 of them is equal 12. 4 plus 3 is what?
7.
7. 7 plus 5,
12.
12, right?
Yes.
Good, good. So that means that X plus 12 is equal 12. So that X is equal 0. So what does that tell you? We don't have maize only, right?
Yes.
Do you understand? Yes, we don't have what? Maize only. So this is for what? Maize only. Maize only, which is equal to what? None of them. Now we'll go again for Y. Y happens to be for yam, right? So let's do for
Yes.
yam. So for yam, values for yam, I have what? Y plus 4 plus 3 plus 2. You know, in exam, you don't have to be so detailed. In exam, you don't have to be so detailed like me here. You can just
Yes.
get your answer. Is equal to, yeah. So the number of yam is equal to 10. So 4 plus 3 is 7. 7 plus 2 is 9. So y plus 9 is equal to 10. Good. So 10. Good. So that means we have just one person, only what? Yam. Only yam. Good. Now, the next one is who? Is Z, right?
Plantain.
We're looking at Z, which is 5 plus 2, 8. Is that not so? 8 plus 2 is 10. 10 plus Z, 10 plus Z, then plus 14. Yeah, so for plantain, so for once you draw that circle, you are good to go. And they've given us, once you draw the circle, yeah, once you draw that circle, all these things I'm doing now is just for us to be detailed a bit for other persons that will go through the video. So now we'll have plantain. For plantain, how many
Z.
persons on that circle for plantain? Can you mention them? So 4, okay, 4 plus 3 plus, sorry, 5 plus 3 plus 2
5
plus
plus
Z.
3
Yeah,
plus 2.
yeah. So 5 plus 3 plus 2 plus Z is equal to, how many of them like plantain? 14,
14.
right? Yeah, 14. So 5 plus 3 is 8. This will give us 10 here. 10 plus Z equal 14. So that Z is equal to 14 minus 10. Good. Well done. So Z is equal to what? 4. And remember that this 4 is what? Only what?
Only plantain.
Only plantain. Good. All right. So that said, you will see that we can now complete this. S plus Y plus Z, right? So universal. So from equation 1, we said X plus Y plus Z plus what again? S plus Y plus Z
5
plus 5
5
plus 4 plus 3.
4 plus
Good.
3 plus 2.
Good. 5 plus 4 plus 3 plus 2 is
Equals to
equal to
universal.
U. This is 0 plus 1 plus
0 plus
4
1
plus 5 plus 4 plus 3 plus 2 equal to universal. 1 plus 4, 5. 5 plus 5, 10.
10.
Good. 10 plus 4, 14. 14 plus 5, that's 19. Is that also? Good. So that U is equal 19. So, and they're asking us what? The group of women, right? So, group women in the group equal 19. So, women in the group equal 19. Women, sorry. So, one thing about this method is that once you draw that equation, even if you make mistake like I did before, you can easily trace your what? Your steps. Is that okay? So let me see if I can. This is JAM 1999. Let me check again. See whether there's another one that we can work on. Okay, this one is P minus Q intercept R. The normal distance. I just want to be solving. I just want to be solving anything that has to do with Venn diagram. Okay, this one says this is JAM 2008. So let me take a screenshot and send as usual. All right. Okay. So this is JAM 2008, and I'm sending now. So all right, let's import it. Let's insert, then we can share our screen. Good. All right. Okay. All right. So look at that very one. A bookseller sells mathematics and English books. If 30 customers buy mathematics, so we have number. The number for mathematics is equal to how many of them? 30. Then for English, number for English is equal to 20. Is that also? Okay, 10 customers buy 2 books altogether. So number that buys maths and English is equal to maths and English is what? 20 buy, okay, 10 customers buy the 2 books altogether. So people that buy the books altogether is about 10 of them. So how many customers do we have altogether? So universal set is being asked of us. Is that also? So let's check quickly. Let's draw it here. So the first one is here. Second one will be here. So then we'll have that maths, n for maths is equal to what? Is equal 30. N for English is equal 20. So we have this my circle is very tiny. I can't even draw 10 inside. Sorry. So let's increase it a bit. All right. So we have 10 in between for the both of them. So number for mathematics is equal 30. Number for English is equal 20. So how many are they all together? We cannot do that unless we get the value of what? X here. I'll get the value of what? Of Y here. But what it means is that X is equal to 30. Do you understand? So people that like maths, customers that bought maths only. Are you there now? Are you seeing it now? Good. So if you do that equation, there's nothing to, it's not a big deal again. If you do those 2 equations, if you do for mathematics, it means that you're going to subtract something right here. So mathematics, you're just going to have that 10 plus X is equal to what? 30. So that X is equal to what? 20, right? So that means you have what? Mathematics what? Only, right? Maths only. Good. This is mathematics. Mathematics only. So the next one is what? English, right? So English, in exam, we don't need all this stress. So English is going to be 10 plus Y equal 20. So that's Y will be equal to what? 20 minus 10. So Y is equal to 10. So this is what? English only. English only. All right. So that said, math only, English only. So what do we have now? We now have that total is what? Universal sets x plus y plus 10 is what we are looking for. So universal x plus y plus 10 is equal to what? S plus y plus 10 is equal to what? Is equal to what we are looking for, right? Total
Yes.
customers.
So it's equal to 40.
Good. So x is what?
Yeah.
X
X
is
is
20,
20.
right?
Yeah.
Good.
Y 10.
Yeah. 20 plus 10 plus 10. So which is what? 40. So total customers equal 40. All right, so that's how to tackle Venn diagram problems. Let me get another one. Let me check online. Let's solve as many as possible. Have you solved those questions on number basis? So that anywhere you see number base in the exam, it should be your mark. In our next class, I should be looking at indices, logarithm, and sorts. And after indices, logarithm, and sorts, the next one is going to be your polynomials. We'll look at polynomials and then binomial theorems. But before then, you should go and watch videos on percentages, decimals, and the rest of them so that we can meet up.
So will you send the
We
video
can
or
meet
should we
up.
go and look for it by ourselves?
I will upload it to the dashboard. I'll upload to the dashboard. Check out for other questions. The other ones that has to do with n square plus 1, integer, all those they are normal set questions. In a survey of 50 newspaper readers, 40 read Champion, 30 read Guardian. How many read both papers? This one says in a survey of 50 newspaper readers, there are 50 of them. 40 will read Champion, 30 read Guardian. How many read both papers? Hmm? Justice, any idea?
You
There
said
should be an
40 will
idea
reach
now.
champion.
Don't worry. Let me insert it. Let me get it and insert so that it will be easier for you. The other questions as well that has to do with those set notations I explained. Go ahead and work on them. Go ahead and work on them. Some of them that has to do with set notation. So I'm trying to insert all those set problems. The one that has to do with Venn diagrams. Let me see how many I can tackle one more before it comes to 12. Okay, look at this number 19. I think that will be the last question I'm going to solve now. We'll do those little ones. Then I solve question number 19. Then I will send the link to questions that you can solve and get your hands dirty. Is that okay? All right. So I'm sending them right away. Let's solve as many as possible. Okay. I will send it to your dashboard. Now for your physics class tomorrow, you are to watch the video on resolution of vectors, which I'm going to upload this night. Watch the video on resolution of vectors so that you will be able to meet up. Hope you are following your chemistry class. Justice, are you up to date? You are not following. Why?
It's not that I'm not following, I'm joining their classes, but I'm not understanding it like that.
So what's happening?
I don't know. I'm trying my best to understand.
To understand him. So is it the barber's fault, or the clipper, or the hair that the barber is trying to barb?
The head, though.
The hair, bar. Okay, so we have to do something on that your head. All right, so let's insert. I want to insert all of them at a go so that we can run with the speed of light. Okay, this one should take this page. This one should take this page. Take this page. Then this one should take this page. Yep. All right, so let's run, bro. Good. Can you see my screen now?
No.
Okay. Now, this is the first one. In a survey of 50 readers, 50 read champion, 30 read guardian. So we'll have our circle. We'll have our circle. So now, how many read boats? X. So 50 read champions. Okay, 50 total of them. So universal set. We'll have that our universal set, universal is equal 50, right? Then champion, 40 read champion. So N for champion is equal to 40. N for guardian is equal to 30. Is that also? Now, but we don't know how many that read only guardian. Let's call it C. Only champion and number that reads only guardian. So for champion, we'll have that C plus X equal 40. So let's just do it quickly here. For guardian, are you there? For guardian, we'll have good. We'll have G plus F 30. That's for guardian. Now, finally, universal. We'll have C
plus X plus G equals
good.
to
Good. So C plus X plus G is equal 50. Remember, these are what? Equation 1. These are what? Equation 2. Good. And these are what? Equation 3. Now, we can sub equation 1 into 3. Is that also? So sub equation 1 into 3. What does that mean? Look at this. We have C plus X equal 40. We have C plus X right here. Did you see that? So which means that we can just plug that in. So we have that 40 plus G equal 50. So that the guardian, only guardian is what? 50 minus 40. Only guardian is equal 10. Are you there now? Now, also from equation 1, from equation 2, good. So from equation 2, we have that, it turned to love emoji. So G plus X equal 30, right? So we have G plus X equal 30. So it means that 10 plus X equal 30. X equal 30 minus 10. X is equal to 20. Have you seen it now? X is equal to 20. So what are we looking for?
C.
How many read boats? So have you seen the answer now? You could see that the final answer will be what? 20. Is that not so? So 20 read boats. Yeah. All right. So this one says that in a group of 500 people, 350 can speak English, 400 people can speak French. Find how many people can speak both English, both languages. So 500 people. So 350 can speak English, goes universal. So we have English, so and English is equal to what? 350. Good. Can speak French. So let's intercept it here. So we have N for French is equal to 400. Find how many people can speak both. We don't know. Our universal is equal to 500. So as always, we'll go for English first. So English. So we'll have let only English be E, let only French be F. So we'll have E plus X is equal to 350. Now let's have for French. So for French, we'll have F plus X equal 400. Then let's have our universal, right? So for
Yes.
universal,
E
we'll
plus
have
X
E plus X
plus X.
plus F, right?
Yes.
Equal 400. Good.
Five.
But we can see something. Is it complete?
500. 500.
Okay. All right. But we can see something here,
Yes.
right?
E plus
So
X
that
is
means
equal
that's good.
to
350 plus F
36.
equal 500. So that F is equal to 500 minus 350. So what will be the value of F now?
150. 150.
So yeah, F equal 150. Now we'll have the value of F. So remember that this is our equation 1. This is equation 1. This is equation 2. We're looking for X, is that also?
Yes.
And this is equation 3. So substitute equation 3 into where? Into equation 2. And equation 2 says that F plus X is 400. So we'll have that F plus X is 400. So that is 150 plus X equal 400. So that X is 400 minus 150. X is equal to what?
150. Which is 250.
Is it
100
250?
for 300. 250.
250. So 50 plus 50, 100. Yeah. So that will give us 250. So you can see that the number there is 250. So both languages. All right. So that has been done right there. Okay. So the next one says in a number of 144 who registered for mathematics, physics, and chemistry in an exam are shown in the Venn diagram. How many registered for physics and mathematics? So now, what are we expected to do? We're going to get the equation for mathematics.
How many?
So for mathematics, we're going to have 42 minus x, is that also? Plus
Yes.
6 plus x plus 2x, is that also?
Yes.
Plus 4x is equal to mathematics, m. Is that also?
Yes.
So let's collect like terms. I'm going to have 42 plus 6, right?
Yes.
Then I'm going to have minus x plus x plus
Yes.
6x equal to m. This part should give us 0. So we're going to have 48 plus 6x equal m. Let's call this our equation number 1. Is it clear?
Yes.
So the next part is physics. Is that not so? Let's look at physics. I know they mentioned chemistry, but let's pay attention. If we have any business with chemistry, we can come back and check. So for physics, physics has the same process. Physics has 4x plus 2x plus 3x plus 30 minus x equal p. So 4x plus 2x is 6x. 6x plus 3x is 9x. So I have x plus 30 is equal to p. So this will give us 8x plus 30 equal p. Is that also? This is our equation number what? Equation number 2. Good. Now, chemistry is 34. So we're going to make reference to the chemistry actually. Chemistry is important to us. So let me do chemistry. Right here. Let me reduce this so I'll be able to see my chemistry value. So now the next guy is chemistry. Is that also?
Yes.
Chemistry. So for chemistry, they gave us the value of chemistry. Can you see that? So we have chemistry, we have 6 plus x plus 2x
plus 3x
plus
plus
3x. Yes.
equals
No,
to
not
6.
plus 30. Yeah, yeah, good. Thank you. So plus, yeah, correct. You're correct. Yeah. Plus 34 equals C. So that means we have 34 plus 6 will give us 40, right? So 40 plus 3x plus 2x, 5x. This is, 40 plus 6x equal C. That's our equation number 3. Now, let's talk about universal. The universal, this chemistry that we calculated might not even be important, but let's just keep going. So we have, universal is going to be what? Universal
Everything.
is everything. No. How will I be seeing this thing now so I will not make mistakes? What do I do? You get? I want to be, so I won't be going up and down.
Okay.
42 minus x and 6 plus x. So 42 minus x plus 6 plus x. 42 minus x, 6 plus x, 2x, 4x. So I have plus 2x plus 4x. Even that chemistry I would do, I don't think is important. Plus 2x plus 4x. That chemistry is not even important. So plus 3x plus 34 plus 3x plus 34. That chemistry is not important. Because we didn't have something. 2x plus 3x plus 34 plus 30 minus x plus 30 minus x is equal to 144. Are you there? Yeah.
Yes.
40 minus 2x, 6x, 2x, 4x, 2x, 4x, 34. Everything is in line now. Everything is, we accommodated everything, right? Everything is in sync. That chemistry is just blocking the place we should have actually used. So now, we're going to have collect like terms. I should have 42 plus 6 plus 6 plus 34. 34 plus what? Plus 30. So I'll now have minus x plus x plus 6 plus, yeah. I've taken away this guy. This guy is off. This guy is off. So I have 2x plus 4x plus 3x. There's 3x. This is 3x.
There's another minus x. Another minus x.
At the edge. Okay. Okay. So I have minus x, then plus 2x plus 4x plus 3x. Is that also?
Yeah.
Equal 144. Any other thing I'm omitting?
No.
Nothing again. This is what? 48, right? Then 48 plus 34. Make sure we don't make mistake. Or let's go like this. 30 plus 34 is 64. 64 plus 48. 64 plus 48.
64 plus
48
is 70.
No,
70.
No, I said 64 plus 48. 64 plus 48 because 8 plus 4 will give us 12 now.
Yes.
Carry 1. So 6 plus 4 is 10.
112.
Yeah, so 10, 112, right? So 112. Now, if you check here, this side will go. this will be 0. So I'm going to be left with minus
minus x
x
plus
plus
2x.
this is 2x plus 4x is 6x plus 3x is 9x. Is that not so?
Yes.
Yeah. So plus 9x
Equals
equal 144.
1,
So
4,
112.
1,
This is
1.
plus 8x equal 114. So 8x equal 114 minus 112. So quickly subtract. What do we have? We should be using calculator to save time in all of this.
1, 3, 2.
One what?
3, 2.
132. So divide both side by 8 by 8. 8 into 13. Let's use the box top method. 8 into 13 is 1, right?
Yes.
So 1 remainder what?
5.
1 remainder 5. Is that what you said?
Yes.
That will give us a decimal. Wait. 42 plus 6 plus 34 plus 30. Battery. 112. Yes. So 4x is 8x plus this 9. To give us 16.5.
16.5.
16.5. Can we have a decimal in this? Let's ensure that there is no error anywhere. 42, then 6 plus x plus 2x plus 4x plus 3x plus 34 plus 30 minus x equal to 144. Okay. So let's quickly go. 42 plus 6 plus 30. Yeah, plus 34. Good. Then we'll have minus x plus x has gone out. Good. So 2x plus 4x is 6x. 6x plus 3x is 9x. But had minus x. 144 minus 112. Right. So let's continue. We had that x will give us what? 16.5. Is that also?
Yes.
That's what mathematics gave us. So x equals 16.5. Right there. So we're looking for physics and chemistry, right? So now we can now get the value of P, right? So from equation 2, 8x plus 30 equal to P. From equation 2, you have 8x. Is it plus or minus? 8x,
Plus.
yeah, plus 30 equal to P. So we have 8, open bracket, 16.5 plus 30. What would that give us? So let me point 8 by 16.5 plus 30. That will give us equal to P. So that P is equal 162. They're asking us. The question says we should find what? How many units are for physics and mathematics? Physics and mathematics. Why are we killing ourselves? So both of them together, they're asking us about 4x. Yeah. This is what they're asking us. Physics and mathematics is this one here, 4x. Do you understand? So there's no need of this equation too. There's no need of all this thing we're solving. I didn't look at the question. I thought they said we should find physics. All right. So we're just looking for physics. Sorry, that's why it's important to read question and mathematics. Always read the question so you don't waste time. Physics and mathematics, which is equal to what? 4x. So that will give us 4 times 16.5. So what would that be? That is equal to what? 66. So this is not the option, no? How many do we start for physics and mathematics? Physics and maths. This one is maths and chemistry. Maths and chemistry 4x. Is there a problem with our value of x? We're having 66 for maths and physics. Maths and physics is 4x. X equals 16.5. Okay, let me look at it again. They said how many registered for physics and mathematics. So how many persons registered for physics and mathematics? So the column for physics and mathematics is not 4x.
Yeah.
So all we need to do is to find the value of x. Unless that value. So universal is 42 minus x plus 6 plus x plus 2x plus 4x plus 3x everything plus 3x plus 34 plus 30 minus x. Good. All of them is equal to 144. So 42 plus 6, 47, 48. 48 plus 34. 48 plus 34. Good. Then plus by 30. That will give us 112. So 112. Bro, you cost it too. The value you gave me is too much now. I was writing 132. I'm not seeing it.
Yeah.
Here, I wrote one. Look at what I wrote here now. 144
Okay.
minus 112. I wrote 130 instead of 32. I didn't even check. This is 32.
No wonder. 32.
This is 10. No wonder that answer is. How can you subtract 114 from there? I'll give you 132. So we have that x is equal to 8 times 4 is 32. Is that also? So
Yes.
x equal to 4. So now physics and mathematics is 4x. So which means that I'm going to do 4 times what? Very simple question. 4 times 4 is what? 16.
16.
Good. So our final answer should be 16. So all this mathematics, physics, we don't even need it. All you need is universal set. So that universal, you add them. I didn't look at it. I was thinking they said that people that do maths, people that do physics, like we do maths different, but they said physics and what? And maths. Which means they're asking us of the number of physics intercepts, mass. So all of these things are just unnecessary. All these things here, this is purely unnecessary. Unnecessary. So all you need to do is just to get your chemistry, get the universal, then mathematics and physics, which is what? Your P intercepts. You just get the number of P intercept M. So you see that equation we're getting will always make the work easier for you. And that is it, Justice. That's the very last question I want us to solve. So go ahead, get questions, get your past questions, solve as many questions as possible. Remember the rules that we started with. All those ones on sets and everything. Just know where we started from. And cardinal formulas, power of sets, cardinality of sets, commutative laws, the commutative laws that we handled, associative law, and everything that I did today. I looked at Venn diagram. We looked at sets. We solved questions on set. I gave you the principles, and I solved as many as possible. So once you solve, there's no question you cannot tackle. So what you need to do now is, I've done everything on Venn diagram and everything. So start solving question that has to do with normal set notation, questions on set notation. And I wish you all the best. So I will the radar recording should be on your dashboard. This recording as well will be uploaded before evening, and I'm going to upload the video you're going to watch because I'm not going to teach that one. That one has to do with approximation, percentages, profit and loss, simple interest. All those things are very easy. So there's no need of me teaching them.
Can they ask us
Yes.
this thing, probability?
Yes, now we're going to do probability, statistics.
Okay.
And that's statistics and probability. So next class will be under indices, logarithms, and sort. I'm going to take 2 hours to handle that. But then the one I want you guys to watch and learn on your own is percentages and percentages, decimals, because your exam is sectioned into 5. You have numbers and numeration. We have numbers and numeration. Right. You have trigonometry. You have statistics and probability. There's another one I'm omitting. There are 5 of them. It has 5 sections. Numbers, algebra, trigonometry. There's another second one I'm omitting right there. Yeah, so geometry and we should be geometry. we have geometry, and then I think trigonometry. So under these numbers now, I've tackled number bases, I've tackled sets, right? The next one I should tackle now is indices and logarithm. Indices, logarithm. Then there's another one which is that decimal, percentages, and the rest. And the last one I think is AP and GP. They are under numbers. They will have algebra. You understand? So I'm picking the most important from there. You know, those I know that questions comes every year. So I will send the syllabus to us as well, right? So there are two things I'm giving you: videos for decimals and numbers, and the rest of them. So all the best, bro. Yeah.
Okay.
Thank you.
That sequence
All right.
involved.
Which one?
Sequence.
Yeah, I'm going to see you guys are going to watch AP and GP on your own for that numbers, right? Because
Okay.
AP and GP is just applying a formula. So you are going to watch AP and GP on your own. You're going to watch decimals, percentages, simple interest, ratio, proportion on your own for under numbers and numeration. Do you understand? So that one is going to be on your own. So I'm going to just pick indices and logarithm. Then when we go over to algebra, for algebra, you're going to work on variation on your own. So I'm going to work on polynomials and binary operations for you guys for algebra. So for geometry, that's where I'm going to treat every topic on it for geometry. Then for statistics and probability, all those mean, mode, variance, standard deviation, you do that one on your own. Then I will tackle probability. So that's how I'm going to do it. So you get set for your exam. All the best, bro. Yeah, remember to revise and solve as many questions as possible. Take care, man. All right. Yeah, peace out then. Any other question? Yeah, we're done. Any other question?
No.
Yeah, confidence. Uh, do you have? There's no. Do you have biology class today?
No. Only math.
Confidence. Do you know? Do you do maths? Yeah, we are done. What did she say? Okay, no. Okay.